In part 1 of lecture 7, we will discuss building the SLR1 state machine. In the previous lecture, we looked at bottom-up parsing with an LR0 grammar, so we will now try it with our original expression grammar, which is not as anemic as the LR expression grammar we used in the previous lecture. And you can see the productions on the slide. Let's try parsing it as we did in the previous lecture's case. We will parse the expression x plus y times z. Our first token is ID, which we will push on the stack. When we see the plus sign that comes afterward, we will reduce by production 5. F derives ID. We pop the identifier and replace it with factor. We then reduce by production 4. T derives F, popping the factor and pushing on a term. We reduce by production 2. E derives T, popping the term and pushing the expression. We then shift past the plus sign, pushing it on the stack, and do the same for identifier. We reduce by production 5, replacing identifier with factor, and then reduce again, replacing factor with the term. And then what? We have a choice. We can either reduce by E derives E plus T, or we can shift, placing the asterisk on the stack. But the problem is, without looking at a look-ahead, we can't say for sure which action should be taken. Before we try an LR1 state machine, we will build an SLR1 state machine, where the S stands for simplified. We see that the process of building the state machine doesn't really look different from the LR0, but as we build it, you will see how it will look different. The initial state looks a lot like the one from the LR0 state machine. We begin with a special start symbol S, deriving our regular start symbol E, followed by the end of file marker. With the dot before the non-terminal E, I need initial items for E. E derives dot E plus T, and E derives dot T. I already have initial items for E, so E derives dot E plus T doesn't give me any new items. But I have the dot before it, the T, in E derives dot T. I now need initial items for T. T derives dot T times F, and T derives dot F. Again, as in the case with expression, T derives dot T times F does not require any additional initial items, but T derives dot F requires initial items for F, and I have them here. F derives dot identifier, and F derives dot open parenthesis E close parenthesis. The transition on E takes me to state 1, where previously I had S derives dot E dollar. In state 1 I have S derives E dot dollar. Where I previously had E derives dot E plus T, I now have E derives E dot plus T. In both cases, the dot is before a terminal, so I don't need any additional items here. The transition on T takes me to state 2, where previously I had E derives dot T, I have E derives T dot, a final item. T derives dot T times F, the transition to state 2, gives me T derives T dot times F. In the first case, I have a final item. The second case, I have the dot before a terminal. And again, there are no new initial items that need to be added here. On F, I go from state 0 to state 3, from T derives dot F to T derives F dot. And here I have only the one final item. On identifier, I go from state 0 to state 4, from F derives dot ID to f derives id dot, another final item alone in its state. On open parenthesis, I will transition from state 0 to state 6. From f derives dot open parenthesis e close parenthesis to f derives open parenthesis dot e close parenthesis. The dot before the e requires initial items for e, as you see here, and the second one, e derives dot t, will now require initial items for t. T derives dot t times f, t derives dot f. The second one of these, t derives dot f, will require initial items for f. F derives dot id, f derives dot open parenthesis e close parenthesis. Please note, the item that you see on the bottom may be from the same production as the item at the top, but they are very different. In the case above, we have already gone past the open parenthesis. In the second case, we are beginning the expression inside the parentheses with another expression inside parentheses. Now that we have transitions from the initial state, state 0, let's take a look at the transitions from the first of the ones that come afterwards. From state 1 on the $sign, we will go to another state, s derives e dollar dot. This will be our acceptance state, and as a matter of practice, we are going to give this the highest number, which means we're not going to number this one yet. Now let's look at the other transition from state 1. On plus, we will go to state 7. From e derives e dot plus t to e derives e plus dot t. With the dot now immediately before term, we need initial items for t. T derives dot t times f, t derives dot f, and again we'll need initial items now for f. F derives dot id and f derives dot open parenthesis e close parenthesis. Now that I have the transitions from state 1, let's take a look at the transition from state 2. E derives t dot is a final item. I have no transitions from there. But t derives t dot times f, I will have a transition on asterisk. T derives t times dot f. This means I now need initial items for f. F derives dot id and f derives dot open parenthesis e close parenthesis. Let's start looking at the transitions from state 6. The first thing that we will see is that there is going to be a transition on t. This will go to state 2, because again we'll have a transition from e derives dot t and t derives dot t times f. It is pretty much the exact same transition that we had earlier from state 0. We will also have a transition on f, and again it will be to state 3, because again we have t derives dot f, and we'll go to state 3 where it is t derives f dot. On identifier, we are going to go to state 4 as we did before, because f derives dot id will transition to f derives id dot. The transition on open parenthesis is a little different, because here we are transitioning from f derives dot open parenthesis e close parenthesis to f derives open parenthesis dot e close parenthesis. We are transitioning through a second expression within parentheses, and although this may seem a little strange, it's a slightly different case than we had before. The last transition from state 6, but not the least, is on E to state 5, where in state 6 I have f derives open parenthesis dot E close parenthesis. In state 5 I have f derives open parenthesis E dot close parenthesis. I also have e derives dot E plus t, which will become in state 5 E derives E dot plus T. In both cases, the dot is before terminals, so there is no need for initial items to be added here. There are two transitions from state 5. Let's deal with the second one first. On plus, I'm going to go from E derives E dot plus T to state 7, E derives E plus dot T. And as before, I'll have the necessary additional items because of that. The other transition is on close parenthesis. E derives open parenthesis E dot close parenthesis to F derives open parenthesis E close parenthesis dot. This is going to be a new state, state 11. I'm now ready to look at the transitions from state 7. The first one will be on T. E derives E plus dot T will become in state 8 E derives E plus T dot. T derives dot T times F will become T derives T dot times F. The transition on F, T derives dot F, will go to state 3, T derives F dot. The transition from state 7 on identifier goes to state 4, from F derives dot ID to F derives ID dot. The last of the transitions from state 7 will be on the open parenthesis, which will take us to state 6, from F derives dot open parenthesis E close parenthesis to F derives open parenthesis dot E close parenthesis. Let's take a look at the transitions from state 9. The first item is T derives T times dot F. That will go to a new state, state 10. T derives T times F dot. We have F derives dot ID. That will go to state 4. F derives ID dot. We also have F derives dot open parenthesis E close parenthesis. This will go to state 6. F derives open parenthesis dot E close parenthesis. Let's take a look at state 8. E derives E plus T dot is a final item. There are no transitions from here. However, T derives T dot times F will have a transition on F to state 9. At this point, it's clear that there are no additional states that we need, and the ones that we have so far are numbered 0 through 11, which means that our final state, our acceptance state, will be state 12.